Hi everyone, this one is actually part 2 for the tutorial question, which is number 8, page 19, number 8. So if I look at here, okay, we continue with the where we stopped at last part. In last video, I state in order to find displacement, we actually find area under velocity time graph, right? So the displacement is actually 180, and in this question I can say the value for the displacement actually equals to the total distance traveled. Why? Because I know the object here. I can say that it's actually never change direction of motion. It's never change. Why I so confirm about this fact? I will found that here. I found that. What do I found? I found that the value of v in this graph always just take the positive value. It's maintain the same sign of convention for the velocity. For example, this one 0, this one positive 20, this one positive 20, this one 0. Never take negative sign in this question. So if this motion we found that all of this just take positive value, you never found a negative value here, means it's always maintain the same direction. Okay, if the object travel, for example, along x-axis only, means in this case it's always travel to the right only, never turn and change the direction and suddenly turn and travel to the left. No, in this case. So that's why I say in this case the displacement actually equals to total distance travel. Okay, so this one is that. And next we move on to the next part. Okay, how about how we're going to draw acceleration time graph. So if you look at here, I draw first the y-axis for this. So this one A, this one is a unit, this one is a time. Okay, so for AB, I might have already found the gradient for the graph AB. I found that yes, positive 5, right? So you just label positive here, positive 5. So this one is graph AB, and then the time here is actually 4. That's it. How about BC? BC I know from part A, we have already stated for BC, acceleration how? 0 acceleration, right? You look back the answer for part A, 0 acceleration. 0 acceleration means the value of the gradient here, okay, means the value, bukan value of the gradient, the value of A here, should be 0, which is here 0. Kalau you baca nilai dekat sini kosong lagi apa? CD gradient dah ada dekat sini kan, gradient negatif 20 negatif berapa, 10 kalau negatif 10 mana dia, so somewhere here, so you gonna label ini negatif 10. So we have this so this one, ini graph yang kita ada. Dan jangan lupa you mesti label masa. Okay, you gonna label masa dekat sini. So this one is our time, and then the unit in second. Jadi ini jawapan untuk bahagian C. And we continue with part D, the last part. What do they want? They ask about apa graph yang mereka minta? Yeah, sesaran versus time. They ask about this. So how are you going to solve this question? No worry. Sama juga, you kena tahu bahawa gradient iaitu keturunan ST graph sebenarnya adalah apa? Adalah mewakili H laju lah kan, gradient for the ST graph, okay, actually represent velocity. Alright, so maksudnya dekat sini. Sebelum itu kita baca dulu nilai V along AB. Di sini dari kosong, velocity actually increasing to 20 kan. Velocity increasing. Kalau velocity increasing, maksudnya gradient should increasing lah. So how you're going to draw gradient which is increasing? So will be something like this. Gradient increasing. How would it be? Okay. How would it be? How are you going to draw gradient increasing? Something like this lah. Okay. Kalau you cuba cari gradient ini dengan ini, you kena dapati memang semakin bertambah lah. Semakin cerun lah. Semakin cerun dalam case ini. So this one is our first part where we have 4 second here lah. Ini first part kita. Then we move on lah. We move on. Macam mana BC? BC, kalau kita baca nilai velocity, maintain same value of velocity, maksudnya constant velocity kan. Kalau velocity constant, maksudnya gradient juga constant lah kan. Jadi macam mana saya nak lukis gradient which is constant here, which is slanted line like this lah. Kalau you tak percaya, you cuba cari gradient bahagian sini dengan gradient bahagian sini. You kena dapati gradient nilai dia sama untuk bahagian ni. Alright. Jadi ini untuk mana? Untuk 10 second sampai. This one is the time interval from 4 to 10 second. So how about the last part? Last part. Okay, last part. Saya dapati kalau saya baca nilai V untuk CD, V dari 20 berkurang sampai apa? Berkurang sampai kosong kan. Maksudnya velocity decreases, right? Kalau velocity decreases, maksudnya gradient juga decrease lah. Macam mana saya nak lambangkan gradient decreases? So will be something like this lah. Curve like this. Gradient decreases. Semakin cerun, dia jadi kurang cerun dah. Okay, so this one will be our graph. Ini saya lukis dengan lebih baik lagi. So will be something like this. Semakin cerun, dia jadi kurang cerun dah. Jadi ini ST graph kita. Okay, jadi so we have 4, 10 and then the next one will be 12 second lah. Jadi bentuk graf kita sepatutnya beginilah. Alright. Jadi untuk tak mengilukan madam padam ni dengan sebenarnya ini 20 ini adalah untuk graf ini ya. Okay. So please label the axis. Make sure all the value here correct. Okay. So the pattern for the graph should be look something like this lah. Okay. Gradient increasing, gradient constant, and then gradient decreases. Okay. And don't forget this one, our unit is actually in meter. Okay. So I think that's all for today. But before that, I might know the value of this one. Displacement kita serasa boleh capai berapa dekat sini. Yeah, you should label this one 180 meter. Supaya dia boleh capai 180 dekat sini. Okay. Jadi untuk soalan ini itu je. Thank you. Bye.